Welcome to CognitionChunks. This information is for entertainment only. I am not trained in physics. Is this useful? Is this nonsense? Join me as I attempt to learn from GPT. Here is Logical Timeless Physics by GPT. Episode 5, The Spatial Symphony, Configurations and Relationships. Exploring physical phenomena through the lens of configurations and relationships instead of traditional dynamics offers a nuanced approach to understanding the universe. This analytical perspective shifts focus from the temporal evolution of systems to their spatial arrangements and inherent connections. Below, I'll outline how this approach is conceptualized, analyze its implications across different scales of physical interaction, and draw logical conclusions about its utility and future applications. Premise: configuration and relationship-centric approach. Detail: traditional physics often emphasizes dynamics, focusing on how physical systems change over time. In contrast, a configuration-centric approach examines how components of a system are arranged at any given moment and how these arrangements define the system's properties. Example: in crystallography, the properties of a material are determined by the arrangement of atoms within the crystal lattice, not primarily by how these atoms move. The strength, electrical conductivity, and optical properties are all emergent from this static configuration. Analysis: implications across physics. Quantum mechanics: in quantum field theory, the relationships between field quanta at different points in space, rather than their temporal evolution, can explain phenomena such as entanglement and superposition. This emphasizes how spatial relationships, rather than individual histories, dictate quantum states. Astrophysics: the large-scale structure of the universe can be understood through the spatial relationships between galaxies and clusters, which influence gravitational clustering and cosmic evolution independent of time-specific dynamics. Statistical mechanics: the thermodynamic properties of a system, like temperature and pressure, can be described through the statistical distribution of particle configurations, focusing on how particles are organized rather than how they move over time. Logical conclusion: theoretical and practical advantages. Reduction in complexity: by focusing on configurations and relationships, scientists can often reduce the complexity of the models needed to describe systems. This is particularly advantageous in fields where dynamic equations are nonlinear and difficult to solve. Enhanced predictive power: this approach can enhance predictive power in systems where dynamic data is limited or noisy. For instance, understanding the static stress points in a bridge's structure through its load-bearing configuration can be more straightforward and predictive of failure points than dynamic stress analysis over time. Informing design and innovation: in engineering and technology design, knowing the optimal configuration of components, like in circuit design or molecular synthesis, can lead to more efficient and innovative products. Further considerations and future research. Interdisciplinary applications: the concept of focusing on configurations and relationships could extend beyond physical sciences to biology, where the spatial arrangement of biomolecules in a cell determines its function, or to network theory in computer science. Advanced modeling techniques: future research could develop more sophisticated tools for analyzing static configurations, possibly employing machine learning to identify optimal arrangements for desired outcomes. By focusing on configurations and relationships rather than dynamics, we can gain a clearer and often more manageable understanding of complex systems. This approach not only simplifies certain scientific analyses but also opens up new avenues for cross-disciplinary research, highlighting the interconnectedness and inherent properties of systems rather than their temporal changes. As science progresses, this perspective may increasingly inform both theoretical advancements and practical applications in technology and industry. Thank you for joining us for another Cognition Chunks. Please like and subscribe.